Hi ladies and gentlemen, this is Mr. Green again, and this is another in my series of lessons for Algebra 2, and we're talking about polynomials, okay? Where last time we combined polynomials by adding and subtracting them, this time we're going to be looking at multiplying polynomials. When you multiply polynomials together, you get another polynomial. Quite simple, okay? It doesn't change that aspect of it. Now, what I want to show you down here, this is called Pascal's triangle. And what it's saying is that when I'm multiplying x times y, okay, or when I multiply some things together, I'm going to get some coefficients. And it's trying to help you understand what the coefficients are in every situation. The coefficient in this one is a 1. The coefficient here and here are both 1s. Coefficients here are 1, 2, and 1. Coefficients here are 1, 3, 3, and 1. What are we doing? These are the coefficients when you start taking something like x plus y raised to some power n. If I'm raising something to the 0th power, it's obviously 1. We've talked about that before. If I'm raising it to the 1st power, there are my coefficients, x plus y. If I'm raising it to the 2nd power, there are my coefficients, 1, 2, and 1. That's really easy to remember. Okay? They left a term off of there. xy. If I raise something to the 3rd power, there are my coefficients. And you notice the powers change here too. Okay? If they're raising something to the 4th power, there are my coefficients and my powers of x and y. It becomes real simple. If you can look at this Pascal's triangle, it becomes really simple to pick out what they are, and you don't have to go through all the multiplication steps. But I'm going to go through and show you some of the multiplication that we can do here. If I'm multiplying two monomials together, the first thing I'm going to do is I'm going to multiply their constant terms. 2 times negative 3 is a negative 6. Next thing I'm going to do is I'm going to pick out one of the variables, x to the 3rd power times x to the 4th power, and I know that using the exponent rules, I can just add those. That'll be x to the 7th power. I'm going to pick out another variable there, x squared and x. That's going to be x to the 2 plus 1, or I'm sorry, y to the 2 plus 1, or y cubed. And then I'm going to pick out any other variables that I might have, and there's not one over here, so I can assume that that is a 1, and I multiply z to the 6th times 1 gives me z to the 6th. And I just multiplied that monomials together. Monomial multiplication should be the easiest of the ones you'll see here. It's when we start taking a monomial and multiplying it times a binomial or a trinomial or anything else that it starts getting more complicated. And what we start doing is the distributive property, where we took a value and we distribute it and multiply it times each of the terms that are in the trinomial in this case. It could be anything over here. If it's a monomial times anything, a polynomial, I'm going to multiply it times each of those terms. So 5 times 2 is 10. A times a squared is a cubed. 5 times negative 7 is minus 35. A times a is a squared. 5 times negative 4 is negative 20. A. And I just found the result of multiplying this monomial times this polynomial. Okay? Shouldn't be a problem doing that one either. You can probably catch on to that real quickly. Now, this is something you were taught in Algebra 1. It's how to multiply a polynomial by a polynomial. What I like to do is use a method I call the square method, because it's going to work for any polynomial, not just binomials times binomials, but for any polynomial whatsoever. So what I'm doing is I'm drawing a little square over here. And once I draw the square, since I've got binomials, I'm going to divide the square into two equal sections. I'm then going to write this 3x right here. 3x. I've got a plus 2. I'm going to write that right here. 2. I'm going to write this x right up here. And I've got a minus 1. Minus 1. And then just like a multiplication table, x times 3x gives me 3x squared. X times 2 gives me 2x. Negative 1 times 3x gives me a minus 3x. And minus 1 times 2 gives me a negative 2. Now the only trick to this is if you look at the diagonals, they're the same, x and x. I need to make certain that I add those together when I write down the full answer. So 3x squared, okay, minus 3 plus 2 gives me a minus 1x or minus x, and then a minus 2. Ta-da. Now, if you want to check this by doing FOIL, you're welcome to do so. 3x times x gives me a 3x squared. 3x times minus 1 is a minus 3x. 2x times x gives me a 2x. 2 times 1 gives me a minus 2. These are like terms here, so they can be combined together, and I get 3x squared minus x minus 2. The reason I like using the square method over here is it really does help me when I get to a little bit bigger problems. So here I've got a formula for the area. That's what they're wanting. Okay? So I've got 3x plus 1. I can draw my little square that I'm going to use to multiply by binomial, write it in here, and I get 3x and 1 and x and 4, and I multiply out and I get 3x squared, I get 12x, I get x, and I get 4, combining my like terms as I'm going. 3x squared plus 13x plus 4. Okay, seems pretty straightforward. Can I use it with a monomial times a polynomial? You know, it works, and I want to show you how it works. Okay, I'm drawing this way. I can write 4p here. I can divide this box up into three things, y3, because it's a trinomial up here. And I've got 2p squared, I've got 3p, and I've got minus 1. Minus 2p times 4p is an 8p squared. P cubed. Okay. 4p times 3p is a 12p squared. And 4p times negative 1 gives me a minus 4p. Now I can just write it all down. 8p to the third plus 12p squared minus 4p. Okay? So let's try this one more time. I'm just going to do this one by FOIL. 3 times 4, 3m times 4m gives me 12m squared. 3m times 8, it gives me a plus 24m. Okay, negative 1 times 4 gives me a minus 4m. And negative 1 times 8 gives me a negative 8. Adding this together, I get 12m squared plus 20m minus 8. Okay, beginning to catch on to this a little bit. What do we do when we got a binomial times trinomial? Okay, that's big enough that I'm going to have to draw my box because I like drawing the boxes. Okay? And I think that personally, I think this way actually helps me keep the record straight in what I'm doing. Okay? what I just did is I've got a y squared that's going to go here. I've got a minus 2. I've got a 4y squared. I've got a minus 3y. And I've got a plus 2. I'm going to take the 4y squared times the y squared, and I'm going to get a 4y to the fourth. I'm going to take a 4y squared times the minus 2, and that's going to give me a minus 8y squared. I've got a y squared times a 3y. That gives me a minus 3y to the third. And I got a minus 3y times the minus 2. That gives me a positive 6y. And I got 2 times the y squared. That's a 2y squared. And a 2 times a negative 2, that's a minus 4. Okay, my problem is my diagonal didn't work here. I've got a y squared here and a y squared over here. The problem was I was missing a term in here, wasn't I? If I'd had another term in here, 0, everything, it would have been on a diagonal and you would have seen it. But you just have to look for those if you don't see them when you first write your problem down. So you just have to look for the like terms to combine them together. So 4y to the fourth minus 3y cubed minus 6y squared plus 6y minus 4. Now, I can hear it right away. Where did you get the minus 6y squared? Minus 8y squared plus 2y gave me the minus 6y squared. That's where it came from. Okay? Let's do another one here. Oh, we got another rectangle. They want us to write the formula for the area. So I'm going to have 2h plus 9. I'm going to draw my little box. You can see my box gets messier as I go along here, guys. Okay? I've got 5 and a minus h. Did it make any difference I wrote it that way? Not at all. I'm going to get a 10h. I'm going to get a 45. I'm going to get a minus 2h squared. And I'm going to get a minus 9h. Okay? I want you to notice my like terms are now right here. Okay? So I'm going to get minus 2h squared plus h plus 45. That would be the formula for the area of this rectangle. So, I've given you my little lesson on multiplying monomials, binomials, trinomials, polynomials together. I hope it helps. If you have any questions, feel free to come to Toga and let's talk about it. Class Connect, we will go over some of this stuff in Class Connect and be ready for the next lesson. I'll see you when I see you.